What causes Python database connection failures and how to fix? Imagine trying to open a door and finding it's stuck or locked. That's similar to what happens when your Python application can't connect to a database. Let's explore what causes these connection failures and how you can fix them. One common reason is incorrect credentials. If the username or password you provide in your code doesn't match what the database expects, the connection will fail. Always double-check your login details and ensure they are correct. Also, verify that the user account has permission to access the database and perform needed operations. Network issues are another big cause. If your application can't reach the database server because of firewall restrictions, wrong host names, or closed ports, connection attempts will fail. Make sure the server's IP address or hostname is correct, the port number is open, and your network is stable. You can test connectivity by pinging the server or using tools like Telnet. Database server configuration can also cause problems. Settings like allowed IP addresses, maximum connections, or timeout limits might block your application. Check the server's configuration files and adjust parameters if necessary. For example, increasing the maximum number of connections can prevent errors during high traffic. Connection limits are often overlooked. Databases set a maximum number of simultaneous connections. If your application opens many connections and doesn't close them properly, you might see errors like maximum user connections exceeded. To avoid this, always close connections after use. Using context managers in Python makes this easy, as they automatically close connections when done. Connection pooling tools like SQL-Kami or Django's ORM help manage connections efficiently, recycling them as needed. Idle connection timeouts can also cause issues. Some servers close connections that stay idle for too long. When your application tries to reuse such a closed connection, errors happen. To prevent this, configure your database client to refresh or recycle connections periodically. Implement error handling so your application can detect closed connections and reconnect smoothly. Driver or library issues are another factor. Using outdated or incompatible database drivers can cause connection failures. Make sure you are using the latest versions of drivers like Scicop2 for PostgreSQL or MySQL Connector Python for MySQL. Compatibility with your database server version is key. Proper error handling in your code is essential. If exceptions like operational error or interface error aren't caught, your application might crash or leave connections open. Wrap your database operations in try-except blocks and ensure you close connections in finally blocks. This keeps your application stable and prevents resource leaks. Practical fixes include always closing your database connections after use. Use Pythons with statement for automatic cleanup. Manage connections with connection pooling tools that recycle connections before the server closes them. Check your credentials and connection parameters before deploying your application. Keep logs of connection errors to spot recurring issues and fix them quickly. By understanding these common causes and applying proper connection management, you can build Python applications that stay connected and work smoothly with your databases. This way, your data operations will be reliable, and your application will run without hiccups.